be live on the audio as well. This is our 5th online meetup, our first for this year. We have just a couple of updates, small update from us on the solo side. And then we have some guest speakers from the community to talk about what they're doing with cloud native tools, Gloo being one of them. And we're very excited to have them here. So first up, we have the blog for this went out late last night, I believe. I should know I published it, but there's a little security for Gloo. So Christian, I don't know if you want to give a little more insight into what these are, the CVEs that were addressed, and the upgrades that folks should be considering making.
Sure, yeah, if you want to go to that slide.
Yeah, do you see it? I just did, let's make sure that folks can see it.
I see just the title slide.
Ooh. That's weird.
Yeah.
Still just title slide for you all?
Yes.
Yeah, it's just online meetup number 5.
No, okay, let me try this. Let me try this again. Because, you know, it can never work 100%, because then that would be weird. All right, let me get to this. Hang on. I will go try this again. Share screen, desktop, share. Now you'll see. So, boom. Do you see the slide?
There we go.
Yay. Okay. And feel free to ask questions as we go, folks.
Yeah, definitely ask questions. So we're going to be, like Betty said, we'll have some end users discussing some of their journey. But I think we're going to kick off here with a little bit of an update. So you can see on the screen here that we have patched Gloo, which is a open source API gateway built on Envoy, to the latest patch releases of Envoy that fix a few CVEs that came in a little bit ago, and it was just announced recently publicly. And so if you're using Gloo, if you're using Envoy on its own, if you're using Istio or other Envoy-based frameworks, application networking frameworks, then we highly recommend that you update that. Do you want me to start a little context about what Gloo is?
For
That'd be
folks,
useful, unless the Frasca folks are going to do that.
well, actually, a little overview on him, a little blurb on it might be good, because then, yeah, the Frasca folks will talk about how they're using it.
Right. Okay. So Gloo is an API gateway built on Envoy, and we specifically chose Envoy to build this type of gateway because Envoy itself was built to be highly dynamic and live in a cloud native environment. So its configuration can be dynamically updated. It can do all of the proxying things that you would expect, like load balancing and TLS termination and rate limiting and so forth. And then what we build on top of it, the API gateway part, it allows you to abstract away differences in the way you implement your API in a particular cluster or set of services versus how you expose that API out to clients that might want to consume it. And you keep that decoupled while you can continue, right? I mean, microservices and cloud native is about moving fast and making changes and so forth. And you want to do that without affecting and forcing your clients to change. So you need that decoupling. That's what an API gateway does. But Gloo and Envoy are very specifically built to live in this cloud native and including Kubernetes native environment.
Cool.
So yeah, from there we can let's take a look at what the Frasca folks have been doing in their journey here.
Oh, hang on one second. Yes, thanks Hunter for sharing the version numbers, but constant releases. Yes, we are. We're always be shipping. But there's 4 different versions there. If you have any issues or questions as you all upgrade, hop into the Slack and ask away. You know, we're there to help you out. And so today, special guests, we have Kevin and Brian from Frasca. They build flight simulation software, and they're going to talk about kind of what they've been doing from adopting Kubernetes and Gloo and cloud native ecosystem of tools. So Kevin and Brian, do you want to start by introducing yourselves and a little bit about your background and how you all came to work at Frasca?
Sure. So I'm Kevin, software architect at Frasca. I've been working here for going on 8 years now. Fresh out of college here, and pretty much my background. College here, and that's it.
I'm Brian Vandre, lead software engineer. I've been at Frasca for, I think, 7 years. I've worked a few places around here. I've always kind of been in this area, but I went to school around here. But
I may have missed it. Where area are you all?
Yeah, Champaign, Urbana, Illinois,
Oh, okay. Awesome.
where the University of Illinois is.
Okay.
More context.
Cool. Well, good to have you.
Yes. So tell us a little bit more about Frasca.
Sure. So Frasca, as I mentioned, we're out of Urbana, Illinois, and we've been doing this for about 60 years, building flight simulators for, I think for customers in over, I think 70 countries. It's actually blocked, I can't see it, but so we build simulators of all levels and all types. So we do, jets, turboprops, helicopters, anything anybody wants to pay us for, we'll do it for them.
Do you have any free ones? I would like to. I'd like to participate.
Could we set up a tour? I know.
Yeah, I mean, I would recommend like everybody, if they want to, if they're more interested, to go check out the website. There's pictures of all our simulators and stuff like that. They're definitely not free. Yeah, so we mostly focus on flight schools and businesses with a little bit of military contracts in there, but we don't have a focus on it. Yeah, so the qualification levels of all different countries, federal FAA for US, we got EASA for European Union, and the Chinese as well. And we are based on our own airport. So if anybody's interested, our airport identifier is C16.
and I actually got to see it out the window there. It's actually behind us right there. Just a little airstrip.
Yeah.
I was gonna half joke that like
That's
if that's a
awesome.
real window or if that's like a simulated image.
Actually surprised it came out well on the webcam. But yeah, it's a little bit about Frasca. We're mostly we do all fabrication in-house. So we are made up of many groups of engineers and
Mechanical engineers, aero engineers,
yeah.
electrical engineers,
And software engineers, right?
software.
And software.
Yes.
The bane of everybody's existence.
Cool. Oops. See if I advance for the next slide for you. Oh yeah, so here's some cool photos if you want to.
Yeah, so this is, I just threw in some examples
That's
of
awesome.
our sims. So this is a cockpit of one of our sims, a Cessna Citation jet. All the avionics are, well, they're actually stimulated. So which means that they are real and we actually feed data to them to drive them. But yeah, that's pretty much what they look like. So we also do
So on the left there, that's the outside of that
same sim.
that
yeah.
same sim. It's set it up on a motion platform with a big dome.
So yeah,
That would be so cool.
I feel like KubeCon Boston. Can we get one of these out there?
Yeah.
$9 million or so. Yeah. Yeah, so we do all sizes and levels. So on the right, we have our basic entry-level sim. That's supposed to be cost-effective for flight schools and smaller, small flight schools. And then on the left was like an example of our highest level sim that we can highest level that you can get in general. So it's on 60-inch actuators, and it's kind of gigantic. Shakes the whole
So
building.
you simulate like Boeing 777s and just any commercial aircraft?
We do regional. We do a regional jet, but most of like Boeing has their own simulation division.
Gotcha.
On sims. We mostly focus on like private pilot kind of stuff.
Gotcha. Okay. Cool.
It's a citation jet, so it's like a small regional jet. If you have a lot of money, you can buy one. But yeah. So in addition to all the simulation stuff, for the simulators, we also collect our own data a lot of the time. And this is just an example of an AS350 that we had out in the field. And there's some arrows pointing to some of the sensors on the external or on the outside of the aircraft. And there's like a million sensors on the inside of the aircraft that you can't see. But anyway, so that's an example. Yeah, so we are not a cloud native company or, cloud company at all. We usually build traditional desktop software because most of our simulators will traditionally have never seen the internet. And that's kind of due to like customer requirements and things like that. We're trying to break that with our upcoming thing that we'll talk about in a minute. But yeah, so our desktop software is actually somewhat similar to like how Kubernetes works. We have multiple nodes, computers that run the simulation, anywhere from 1 to like 24 computers that run the simulation. All of the software is versioned, and the customer is allowed to run any version that they want. We have an orchestrator behind the scenes that runs all the software on each of the nodes, kind of like Kubernetes. But yeah, so then we also do traditional GUI applications for that that interact with the simulation and allow like a flight instructor to modify the simulation and while it's in progress. Like introduce failures in the aircraft or things like that, change the weather in the simulation. And most of our software that we do in-house is written in C#, .NET, or C++. And we also support integrating with third parties. So sometimes the customer has a requirement that like they want to work with a certain type of visual system, which is like what you see out in the world. And we'll interface with them for that. So it's kind of crazy sometimes. So yeah, that's kind of what we have right now.
I'll say a question for you. The previous slide showed like the data capture that you're doing, that you would, assuming that that's the stuff, some of that data makes it into the simulation software. Like, if it's all desktop software, like how do you send out like new data packs, like packs of, more info?
Yeah, so I guess one thing I should mention is that all of our software, when a customer comes in and says, hey, we want, in this case, an ASU50, which is the helicopter you saw in the previous slide, we actually like build the entire simulation specific for that aircraft. So if they require an update for whatever reason, like we're fixing bugs or we have to tune something for them, which means changing the parameter of the simulation, we actually like ship that software again to them, and it includes all that data or whatever data was manipulated with that.
But traditionally, the way like qualification works with the various different FAA, they'll come in and they'll test the simulation, and then they kind of put their stamp on it and qualify it. And then technically, you can't really like change the software all that much or any of the models, or so there's not really a lot of
Yeah.
updates in the models once it's kind of approved.
Okay.
That's kind of convenient, at least for people shipping software.
Yeah. That's kind of, yeah, that's cool. I was curious because I was wondering if some of the things that you're working on that we'll be teasing in for the future slides, if that, if that process improves at all by going, with the things that you're doing.
We do hope that it'll be much easier to deploy updates when we need to, for sure.
Okay. Ready for the next slide?
Yeah.
Okay.
So kind of the simulation that I was just talking about for the rest of the presentation or whatever, I'm just going to say this is a black box called simulation because we'll go over how the cloud interacts with that. Our simulation is stateful, and it is specifically targeting a specific aircraft for a specific customer as well. So there's a lot of craziness that happens inside. And again, our simulators don't normally see internet access, so in the next, or one slide, I'll show you how we're going to connect to that.
All right.
So yeah, we have this desire to kind of bring the simulation to the cloud for a few reasons. I can't talk about all of them, but basically, we want to bring there's a pilot shortage in this right now, and we want to try to combat that a little bit by helping bring the simulator students and flight instructors together via the cloud. And that's our primary objective. But as far as specifics, I can't really go over that. But
Would you be able to answer where the software would live in the cloud and that would be remotely delivered to a actual simulating device, or?
So yeah, we can talk about architecture. That's fine. So
You want me to advance to the next?
sure, yeah. Yeah. Basically, our simulation will still live on the device itself, the actual simulator. We're just going to bridge the gap where we take that simulation and feed data back to the cloud so that we can use it in different states or things like that. Essentially, people can remotely control the simulator and administrate the simulator.
I see.
So yeah, so we are moving to the cloud or bringing cloud components. We're currently running on Azure Kubernetes service, AKS. No particular reason why we chose AKS other than we're kind of a Microsoft shop in here. Not that we necessarily want to be. It's just that's just kind of upper level decisions. But we are designing the whole infrastructure so that it's not tied to AKS. So if we need one decide hey, AKS is we're having issues with it, let's bring it over to G Cloud or AWS or something like that. We can do that. But yeah. So of course we're using Gloo as our API gateway, specifically the open source version. And we're using that to access, obviously various components or services within the Kubernetes cluster. We're tying everything together via service mesh, specifically Linkerd. We like the simplicity of it, and it gives us what we need.
I'm just curious, what part of Linkerd are you all using?
Just what we're...
I missed, the question could be phrased better. So what are the capabilities that most excited you about Linkerd that they do really well that you're interested in?
Yeah, so right now, there's a few things. We really like the traffic split stuff, and that's kind of true of every service mesh, but it seems to work well with our CI/CD system that we're using. But also we're like in development right now, so we don't really have a production server. But just for debugging purposes, it's like really convenient to just like fuck up and say, I'm looking at this service, I want to see network to this route, what's happening, and it just like works.
Yeah.
It is also nice that it just automatically mutual TLSs all of our services and everything together. We're not focused on that, but it is nice because then we don't have that burden on ourselves.
Yeah, no, Linkerd is great. That's what I was curious about. Thanks.
So right now we are serving out web pages from to the internet, and we are using Cert Manager and Linkerd to make them HTTPS compliant. Mostly because we're lazy, it just does it for us. So no point in reinventing the wheel. How we feel about it. And then Gloo on top of that works really well with the Cert Manager. We also, so for data storage and persistence, we primarily focus on managed solutions, mostly because we're a small team and we don't really have the manpower to like administer a database. So it's kind of helpful if some of that burden is put onto the cloud provider, in this case, Azure. So right now we're using a SQL Server and Cosmos with a Mongo interface to it. And then that's pretty much it for data persistence. We do inside the cluster have some Redis caches and things like that. Those aren't managed, those are just per service driven things. And finally, all of our microservices, like I said, we're a Microsoft shop. So a lot of them are written in ASP.NET Core 3.1 specifically. And that's C#. And then we have a few little small things in Rust as well. But yeah.
And then question for you actually, is this, were you from the simulation software that you've been traditionally shipping, and with this, are you guys rewriting it or taking what you had and kind of just breaking it out?
So our simulation is going to stay the same for the most part, and that's primarily due to being able to support like our stuff that's already been shipped out the door and things like that.
Our old our software right now, simulation software, it already has interfaces for manipulating it. Specifically, right, it was developed for like a GUI sitting there. So what we've done is left that all alone, and now we're adding a little piece that will talk to that interface, and it's basically kind of forwarding that up into the cloud so that it can be accessed from the cloud. And it's kind of the simplified reasoning there of the architecture.
So actually, in the next slide, you'll actually see kind of a diagram with that kind of laid out. If we want to get into this, so on the left side, we have the physical simulator like at a customer's facility, and then on the right side we have a Kubernetes cluster, and this is very simplified. So like I took out the Gloo gateways and things like that, but so on the left side, to focus on that for a second, there's our simulation black box that I mentioned, and it just, like Brian said, it already has interfaces out that you can interact with via TCP and UDP. And we wrote this API gateway essentially on top of that, or using those protocols to interface with simulation. And that API gateway is a server or a gRPC server. So essentially anything can connect to it. Even third parties can connect to our simulation, and we've standardized everything so that it shouldn't break when we have different aircraft models, which is a huge challenge. Um, so that's the box off to the right of the black box. And then, so then since the simulation API gateway is a server, it's kind of hard because of firewalls for the cloud to go down to the SIM. So we actually wrote a proxy that pushes out to the cloud rather than the cloud accessing. And that's mostly for getting around the firewall, the NAT firewall. And then, so yeah, so all of that's, we rewrote our orchestrator that was previously in our simulation black box. And that orchestrator now handles like connecting to the SIM and authenticating the SIM with the cloud. The cloud returns some JWT tokens back, and the orchestrator pushes those out to the software components that care about it. So it essentially starts with an environment variable. It says, here's your JWT. Good luck, have fun. So yeah, that's all goes through a virtual service that we have in Gloo in Kubernetes. It handles all the simulation specific stuff. And it is configured for mutual TLS on the ingress side. So the orchestrator will actually give a cert to Gloo saying, hey, this is who I am. And that's forwarded onto our identity server that will verify all that information. And then if it's verified, it goes back through. And then the actual simulation will talk to that same virtual service. Gloo is just doing some reverse proxying for us here. There's multiple services involved, but Gloo ties it all together, which is nice. And yeah, so when that Gloo virtual service gets that data in, it actually pushes it off to a server service called, right here, it's called the Simulation API Gateway, but it's in Kubernetes. So the fun thing about that is the public side of it is the exact same thing that runs on the simulation on the left. It's just tuned for the cloud. So, but the difference is, the nice thing about it is that any service talking to it, either in the cloud or not in the cloud, is talking to the same API. So that way we can take some of our services. Sometimes we have a limitation where we have to run on the simulation, we can't have a cloud. So that lets us take our services that are meant for the cloud and put them on the device, and it's talking to the same API, it doesn't care. And to make it stateless, we back everything with Redis. So we just push the simulator state to Redis. And when you want to get data out of it, it just reads it from Redis. Pretty straightforward. So our identity server, we have, we're using an open source implementation of OpenID and OpenID Connect and OAuth 2. Specifically Identity Server 4, it's a .NET application or API. We've just built on top of it to support things like our mutual TLS stuff. Pretty straightforward. All the services will go to that identity server to verify their JWTs with that. And so it makes it really easy.
How many Envoy proxies that are managed by Gloo here are you deployed?
Right now we have one Envoy gateway proxy managed by Gloo, and it's just making multiple virtual services right now.
Yeah.
With, I don't know, how many upstreams, probably 20, 25 upstreams right now. I don't remember off the top of my head.
Yeah.
And
are the routes that you build into the virtual services, are they fairly complicated? Like, are there a lot of them and regular expression matching and transformations, all that stuff, or is it just fairly straightforward?
So we try to, at least I do, is try to keep it as simple as possible. So I try to match prefix matches as much as I can. We do have a handful of regular expression matches forwarding off to like a function. But we try to keep it dumbed down so that anybody from the team can come in and see what's going on.
Yeah.
Because really only one or two of us have actually interacted with the Gloo at all. So yeah, makes it easy to train if we can just keep it simple.
Yep. Definitely.
There are some, so yeah, all of our services are basically gRPC enabled, so they all intercommunicate with gRPC. With a handful of them having some HTTP, like this is designed for the user to talk with endpoints. We haven't actually done it in practice. I've done it in experiments, but we do like the ability to like translate gRPC to HTTP REST. That's kind of attractive to us. We do have something coming out that we want to actually use that for, but we haven't actually put it into practice. So that's kind of nice. So yeah, pretty much our architecture. We do have like a little operator running, custom operator. The user portal is written in Angular, like what the user interacts with. And yeah, we just have Gloo tying everything together, really. And,
Gluing things together, you think?
yeah, there you go. Every one of those black lines is got Linkerd enabled on it. We pretty much, the whole cluster has it. So kind of works really well.
I think one reason we really like Gloo is because, well, at least I like Gloo is since everything's Kubernetes enabled and everything, we're pushing everything through CI/CD, kind of thing. It's kind of all handled for us a little bit.
Yeah.
So we're hoping in theory, like if we would ever have to, go to a new cluster, and we're kind of thinking we might have to if they like go to Europe, because we want the latency to be pretty nice. Like we might need clusters in different areas of the world. So we're kind of hoping that we've set up something with Gloo especially, but that we can quickly spin up new clusters, maybe in different geographies.
That's such an important consideration, right? Where your source of truth for your infrastructure is actually in document like YAML files or code or something, and not the actual deployment itself. And so when we built Gloo, adhering to that declarative configuration was super important.
Yeah. We like the idea of just, it's very important to us. And this has come back to our like traditional simulation software is like, there's some history that I can go to and say, this is exactly what's running in the cloud.
Right.
Or in this case, or running on the simulator or whatever. So having that source of truth is very important to us as a company.
Yeah, the declarative infrastructure was a deal breaker for us when we evaluated a couple of products.
Yeah.
Yeah, right. I mean, there's some, I don't have to go too far, but there are some products that had the traditional, imperative based configuration model, and then they're trying to bring that over to a declarative model. But we've had really good, I think, adoption of our API and good feedback on the API, because we've had that built with that assumption from the very beginning. That was our, that is an important part of building a cloud native proxy.
Actually, going on that topic is like, one of the things that is attractive to Gloo for me as well is that the YAML definitions and schema were just intuitive. Like I can get in there and understand it. So we previously were running before Gloo, running in the Nginx ingress, and like configuring a lot of it was like a pain in the ass. To keep it short, and then when you had to debug something, it was just insane sometimes. So the custom resource definitions was a big win for me because it was just intuitive. Pretty much all we have for our architecture overview and kind of what we're doing. We hope we have some beta tests coming up with the customer. Probably in a month or two that we hope succeeds, and we'll see how everything works in a live environment rather than here at the office.
So the beta test, the new customer beta test is with this architecture.
Correct. Yeah.
Cool.
So there's we have a
They're a previous customer. They already have our devices.
You're switching to this model. Got it. Yeah.
And they're open to feedback and everything like that, so they understand that stuff is going to be broken. But they're willing to work with us, so that's cool.
What's been your experience with like either getting things to work, or the Slack community or the docs? Can you give us a little feedback on that?
So the Slack community is wonderful. I would recommend anybody who's on Slack to get in Slack.
Well, you all are very active in there too, helping answer questions. So thank you.
Yeah, I appreciate that. Yeah.
So I've like received so much help from the guys at Solo. So like it's kind of just like a pay it forward kind of thing. So if I know the answer to something, I'll just try it quickly.
Yeah, we appreciate it.
But so the Slack docs are nice. So every once in a while, we see it like in the Slack community as well. There's a gap in the docs or something. So usually the Slack makes up for it, and then docs usually get updated. Or there's always a GitHub issue made as soon as someone brings it up in Slack.
Yeah, we're trying to keep up with the docs.
We accept issues and PRs if anybody wants to help out.
So yeah, the one thing that was nice, so I've actually made a few PRs against the Gloo code base. So like the one thing that was helpful in the docs for sure was that like at the time I was doing this, there was nice instructions for how to like set up the build environment, especially this is pre having modules in Go. So like understanding some of that. And I'm not a Go expert, so like it was nice to have a little walkthrough of what I'm doing. So that was
awesome.
Cool.
Yeah, that's pretty much limited experience there.
Yeah, thank you.
I want to say for folks that are online, does anybody have any questions for Brian and Kevin? I think you can unmute yourself.
Yeah, ask questions. Go for it.
I'll just No, everyone's quietly listening today. Okay, that's all right too. No worries. Brian, I don't know if you're in the Slack, but I see Kevin in the Slack. So folks, you can find Kevin too directly.
Yeah, just Kevin right now. I'm not in it, but I'll join.
Come join the fold, Brian. Come on in. The water's warm. Yeah, so okay.
Or whatever, if you have questions. It doesn't have to be specifically about Gloo or anything like that. So if you have questions about the simulation, I'm happy to answer them. So yeah.
Yeah, I think I definitely want the opportunity at some point to try one of these simulation things. It sounds pretty cool.
Actually, when you first asked for this meetup or whatever, I didn't know it was like an online thing at first, and I thought you were like coming here or I was going there, and I was like super confused. And I was like, well, at least I got to try this in.
Oh,
I think the next one is in person.
Yeah, wait a minute. Are you saying you all have a place to do an in-person meetup? Because we can make that happen.
I don't think, but
we can make that happen, and then everyone gets a turn in the simulator.
you got to come when there's a really good sim on the floor.
Yeah. Okay, let's putting a pin in that. We're gonna have to look into that for the future. But also, I have tagged in here link to your website because there's some really amazing pictures in there for the types of simulators you have now, and also like the history is super interesting.
Oh, yeah.
Like those giant, computers that take up the entire wall from the early days, and then. If you want to geek out on this, your Twitter handle has a lot of great pics from, I thought they were super cool because they're not, software conferences there, but you're saying it's very run of the mill for it's
Yeah.
you know, aviation conferences, but you know, having one of those simulators in your show floor seemed pretty neat to me. So if y'all want to geek out on some cool aviation photos, there's some links there for you.
Yeah. Hit me up on Slack if you want to know more. So
Yes, I will post the video with your Slack handle in the channel so that people can find you. So yeah, thank you, Brian and Kevin. Thank you so much for taking the time to, you know, it takes time to prep for things like this and also speak. And I'm sure lots of folks will be hitting you up on Slack. And for those online with us, we'll have, we've got a lot of upcoming events, most of them virtual online events. We have a couple of, like a hoot session next week or the week after, and then another chat with Christian and Nick Jackson of HashiCorp, continuing their service mesh for the developer series, and then more webinars coming. So lots of things, opportunities to learn and dig deeper. If there are topics you specifically want to hear about, just DM me on Slack, and then we can get those on the schedule. You know, we'll just create a backlog of all the things people want to know about. And resource-wise, if you go to, there's a section on the website where we are posting a lot of new resources. The blog has moved under there, so it's no longer on Medium. And then also the all the Hoot live streams that we've been doing to dig into each service mesh, I've kind of batched them all in together into one page, so it's easy to browse. And then all of Nick and Christian's chats are in one page as well. And then if you're not in our Slack, there's a link to our Slack there. And then also if you want to get a little more involved in the projects themselves, file an issue, you know, or, you know, submit a PR, star a repo, whatever, there's a link to our